Okay, so this is higher question 1, foundation question 5. So we've got here a diagram of the top section of the periodic table, and you're told that the letters in here are not the chemical symbols, and you're asked to identify a number of different elements using the descriptions here. So perhaps a good way to start this would be to label the groups, which are the columns of this table, and the periods, which are the rows. Okay, so this is group 1, this is group 2, this is 3, 4, 5, 6, 7, and 0. And here we have period 1, which includes these two elements, hydrogen and helium, period 2, 3, 4, and 5. Okay, now having done that, that makes our life much easier for the first question because it asks us to identify the elements in group 5, period 3. So this is group 5, and there is only one element present, and it is in group 3, sorry, period 3. So that would be G. The element that forms two ions. Now, this is a slightly more difficult question, and if you're struggling with a question, it's always a good idea to seek help in the resources available. So if we turn to the back page, here's one I prepared earlier, we find this list of ions. Now, we're looking for an element that forms two ions, and actually in this table, there's only one, which is iron. Iron forms iron 2 plus and iron 3. If we have a quick look at the periodic table, we'll notice that iron is found in this section of the table, the transition elements. And if we go back to our question, we can see that letter F appears in the right place. Okay, so that's F. Now, an element which forms a 2 minus ion. Now, when an atom becomes an ion, it does so to get a full outer shell. And if it forms a 2 minus ion, that tells us that it's gained 2 electrons. So if it's gained 2 electrons, it must have had 6 to start with in its outer shell, because in gaining 2, it gets 8 electrons, which gives it a full outer shell. So if it had 6 electrons in its outer shell, that tells us it is in group 6, which is this group here, and there is only one element present that is in group 6, so that must mean that's an A. Okay, so this element here forms a 2 minus ion when it gains a full outer shell. The next question asks us for an element which is completely unreactive. Now, the elements that are unreactive are those with a full outer shell, and the elements of the full outer shell are the ones in group 0. Okay, so the only reasonable answer is B. The next question says the element with an electronic structure of 2, 8, 1. Okay, now there's a few bits of information we can get from that configuration. First of all, there are 3 numbers in the configuration. That means it's in period 3. And the last number is a 1. That's 1 electron in the outer shell. So that must mean it's in group 1. Okay, so if we have a look at our available options, this is group 1. There's only one element present. It is in period 3. Therefore, that is answer D. And then finally, for this part of the question, group 2, period 2. Okay, so as we've previously labelled the groups and the periods, this should be quite easy. So here's group 2, and here's period 2. That makes it H. Okay, this question, we've got 5 diagrams of various electronic configurations, and the question asks us for the number diagram, which is the element below element E. Okay, so if we have a look back at element E, we find the element E is in group 3, so that means its configuration is going to end in a 3, and it's in period 2, which tells us there are 2 numbers in its electron configuration. And so the only number that it can be is a 2, because 2 is the number of electrons found in a full shell, and there's only one shell beneath that one. So this element here is also going to have 3 electrons in its outer shell, but it's going to have 3 shells occupied. Both of the other 2 are going to be full. So we already know that the first shell is full with 2 electrons in it, and the second shell is full with 8 electrons in it. Therefore, the electron configuration of this element here is 2, 8, 3. Now, if we have a look at the available diagrams, there's actually only one diagram that's got 3 shells. And if we just double check to make sure that we've not made a mistake, Got 2 electrons in the first shell, 8 electrons in the second shell, and 3 electrons in the third shell. So that means the answer is number 4. Okay, this question here deals with isotopes. Isotopes have the same number of protons. And we know the protons from the atomic number. And incidentally, because they are atoms, it's also the same number of electrons. Okay, so protons and electrons are the same in atoms, not in ions, but they are in atoms. But they have a different number of neutrons. Okay, so there are 3 marks for this question. So if you look at the first column here, the number of protons is the atomic number, and they're all xenon, so they're all 54. Now, because these are all atoms and electrically neutral, then the number of electrons is the same as the number of protons, because they balance or cancel each other out. So that's 54, 54, 54, and 54. However, the number of neutrons is different, and we calculate the number of neutrons by doing a simple calculation. 129, that's the mass of the first isotope. Take away 54, because 129 is the mass of protons and neutrons. If we take away the number of protons, we're left with the number of neutrons. So 9 take away 4 is a 5, 2 take away 5 doesn't go, 12 take away 5 is 7. So this is 75. And then to fill the rest of them in, we notice that 131 is 2 bigger than 129. So that must be 77. 132 is 1 bigger than 131. So that must be 78. 134 is 2 bigger than 132, and that must be 80. Okay, so here a mark for each of the columns.